Yeah, hi, good evening, everyone. Welcome to week 8 live coding session.
Good evening, sir.
Okay.
Good evening, sir.
Good evening. Quickly share the screen. So, I'm releasing the problem. Week 8. Three problems. We have three problems, and third problem is easy. Okay, but the first two problems are a little bit tricky. So, you can try, but if you are not able to solve, then we will discuss the solution. Uh, Before starting the B case, so last week actually uh, we have stuck in one solution week 6, problem number 3. I think this is. So anyone have tried this problem solution? If you remember this binary search problem, those who have solved this problem, they can continue from the B8 problem. Uh, Meanwhile, I'll discuss this previous problem. So if you remember this problem statement, a right function find kth largest element that accept root as a reference of the root node of the BST of an element, and where there is one k value is given. So we need to find out the kth largest element without doing any modification in binary search tree. The complexity of the solution should be in order of log n plus k. So in the last session we tried, but that solution actually was not working for some tests, some corner cases. So anyone tried this problem?
So not yet. So, but one thing we noticed that the class notes and everything code is actually for kth smallest. So that the typo, the lecture notes and the code.
Uh, you are talking about the class video lecture?
Yes, sir. Video lecture
Yeah,
as well as the code in the
yeah.
lecture.
Actually, the term is actually interchange. I think we are finding the largest and using the term. I think smallest. Correct?
The code is for kth smallest, but
Smallest.
the
Okay.
title and everything is saying kth largest.
Okay. Yeah. Yeah, so you can follow the code from the GitHub notes. I think we have corrected that things on the GitHub notes, and we are using the correct term for the for the implementation. So if you are finding any incorrect things, you can just cross check with the GitHub notes. Yeah. Okay, so this problem now just quickly. So the solution for this, we change the solution. Uh, where is the solution? One second, main document. So if you remember the
Sir, sorry to interrupt, but is this week 6 or week 8?
no, this week is 8, but in the previous live coding session we discussed this problem, and the solution was incorrect actually.
This problem is week 6.
Yeah, this problem is week 6, and I have released the week 8 problem as well. Just refresh the page and you can just try to solve from the first question. Okay, so if you remember this problem, we have one binary search tree. So like suppose like 10, first. Okay, suppose this binary search tree is given, and we want to find out the second largest element in this binary search tree. Okay, second largest element in this binary search tree. So first largest we can easily find out. We can simply traverse the rightmost path. Okay, right child, and so last right most child is actually a largest element in this binary search tree. So how we can find the second largest or third largest? So here we are just giving this k value. K equal to 2 means second largest, and root reference is given for the binary search tree. So how we can simply find out this second largest element in log n? Log n means the height of the tree and plus k steps. Okay. So what we can do, if you remember the traversal method, if you remember the traversal method, we discussed three type of traversal: in order, okay, and pre-order and post order. Okay, if you remember the in order process, we just traverse the left child first and print node and right child. Okay, so this is the steps for the in order traversal. We just visit the left node, and then we print current node, and then we visit the right child node. Okay, similar for pre-order, we first print current node, then move to the left child node, and then move to the right child node. So these three steps are we used for the pre-order traversal. And post-order traversal, we use first visit left child node, then right child node, then print the current node. So these three steps actually we use in the traversal method recursively. So similar to find out the first, second, third largest, we can just use opposite of uh, opposite of this in order traversal. Okay, opposite means in this traversing we can simply follow first visit right child node, then print node, and print current node, then left child node. Okay,
So
so
how do
this
you come up with this logic? I mean, I think this is the critical part. Once
huh,
we know, then we'll code it and all that, right? So how do you know that to answer this question, this is the method?
yes. So because we know that where is the first largest element. Okay, so in order traversal, if you just dry run the in order traversal on the binary search tree, then you can see we always start from the root node, then we move to the left. Okay, then next first step is left, then we move to the left this side. So after reaching at the leftmost child, then we start process the printing for like this: 1, then 5, then 8. Okay, in that way, then we move to this side. Okay, in like this. Okay, this similar to this time we want to find out the first largest, then second largest in this order. So we have to move the right side first, then we have to traverse the node in order way.
Got it.
Okay,
So that means our largest element is the first largest, whatever it is going to be on the extreme right. So that is why we have to
yes,
start with right. Okay, makes sense.
yes. Okay, so now we will move to the right side, right side. So when we are reaching the rightmost child, this is the first largest. Now at the time of reversing, so we will follow this in order reverse process. So then we will just come to the this node. So this node will become second largest, then we will move to this node, this will become third largest, then we will move back, then this will become fourth largest, like this. Okay, so during this traversal in this way, we will simply use the counter, and we will also check the counter. So we will start counter from 0. Okay, and k value is given every time when we are reaching at this last node. Okay, so this is the recursive approach. We, after reaching the last node, we will use this counter process and we will increment this counter. Okay, so our recursive call, we will reach at the maximum node. Okay, and at that time we will start reverse process. Okay, so this is a back process. So at that time we will increment this counter by 1. Okay, every time when we are just reversing back to the node, we will just increment this counter, and we will perform this process until when we are reaching this kth value. Okay, until our count value is less than equal to k. We will repeat this process. Okay, so we will just recursively call the left child or right child in that way. We will repeat this process until our count is less than equal to k. At any time when we are reaching, when our count is equal to k, at that time we will not call the recursive part. Okay, so our recursive call will not happen at that time. So our process will only run. So like suppose if we want to find out the second largest, so we will just reach this part. After reaching this part, so here you can see this is the last node, so there is no left, there is then we will just use okay, so we will use right and print and left. So there is no right after that. Then we will use increment counter by 1, and then there is no left. Okay, so one counter we have reached. Now we will move back. So this is the right part of the right call of the from the 15. Okay, so now right call is completed for from the 15. Now next step is increment the counter. So here we will increment our counter, count equal to 2. Now you can see at this time we are getting count equal to k. So now we will stop the call, recursive call on the remaining childs. Then our call will back to the origin of the main call. Okay, so this remaining call will not be happen due to this count condition. So we are only visiting that node. First we are reaching till the first maximum node, then we are simply traversing the node according to our kth value. So now you can see the logic in code. So if you see, we have simply called this is the main function, and we have just initialized count equal to 0, result equal to -1. Okay, and this is the main function which we need to write. And now we are simply calling the our function, recursive function, and we are passing the root node reference and kth value. And we are, after completion of this call, we are returning the result value. Okay, so result is the value of kth element. Now in this function, you can see we are simply taking a variable, and we are assigning this parameter in this variable temp2, and we are also using this global value inside the recursive function, count and result. And after that, you can see if temp2 does not equal to none. Okay, so these condition we taken because our tree structure is actually adding one more node at the leaf. This is actually dummy node. So like this. So after so this is the actual leaf node. Okay, but in our implementation, one dummy node is also added on the left and right child. Actually the value of this dummy node is none. Okay, so at the time of visit this rightmost child, we will not visit this node. Okay, so because this is a dummy node. Okay, so so this one is actually a rightmost child. So according to this implementation, we have just mentioned this condition if temp2 does not equal to none and temp2 dot value does not equal to none. Okay, because we don't want to move the dummy node, which is actually connected on the left or right. So if this condition is true, then we will also check if our count is less than equal to k. Then we will call before calling also. So to just ignore this dummy node, we are simply checking this because we will reach this dummy node. So this is temp dot value does not equal to none. Yeah, so to just prevent the extra steps, we can remove this condition, but we will find some one extra steps on the left or right child. So we are just preventing this extra steps. We have also taken this condition. So at the time of leaf node, at the time of reaching of the leaf node, we will not move to the right child or left child. Okay, that actually a dummy node. So we will check this condition, temp2 dot write dot value does not equal to none. So that means that is a actual leaf node, and we will simply call this kth element with this recursive function on the right child. Okay, so this is actually a first step on the right child visit. Okay, according to my this in order reverse traversal method, first we will move to the right, then we will increment our counter, then we will move to the left. Okay, so the both things we are doing here. So first we are traversing the right child, then we are incrementing our counter. If our counter equal to k, after increment our counter, we will simply check if our counter is now equal to k, then we will store the result, current node value in the result, and we will just check the next things, we will call the left child node part. Okay, so you can see when we are our counter is become k, so in the next call this if condition will become failed, and so we will not call the recursive part again. Okay, so because of that we are checking applying this condition. Okay, so at any time when we are just reaching this kth value, so we are stopping our recursive call. So in that way this graph, this tree will be traversed, and we can find out our result. Okay, so this is also passing the test case, and this also passing the all corner case, so which last time that was not passed actually. If our trees look like only the left side, so that test case was not handled in the previous session solution. So this is the updated solution, and you can just so we will release the solution. I think we have released, so you can see the solution and just go through it.
So here in the second line, we are making another copy or a reference.
We can
Pointer,
ignore this.
pointer.
Yeah, we can ignore this. We can use
Okay.
the same temp one.
Yeah, because I was thinking like we are kind of.
No, no, no. We can ignore this. So we
Yeah.
just used.
So if we start at the root node and then we kind of keep going, we reach like the rightmost.
Hmm.
This is where I think the
Yeah.
right value will be none.
Yes. After reaching at the rightmost child, so there is no node after that. So our second step will be performed actually. Okay. So
Right.
that is the this part.
Yeah.
Okay. This is the mainly processing part in between the recursive call. So we are incrementing count, and then we are just checking our count is equal to k, or then this is the left recursive call.
Yeah. So somehow, temp, it's hard to visualize. We always write like current node, next node, or save node, so that way at least, to keep the thought process more
Yeah,
aligned.
so because of that, just try to make things on the paper and pen, and just check this how your code is actually flowing on the Vani search tree. So in that way you can identify.
So that means this is actually on a different data structure. If the data structure is BST, how to do
No, this is
find?
VST. This is VST.
Yeah. So we can do the same thing on an array also, right? Which is a linear data structure.
So that
Now,
means
so basically, depending on the data structure, how the time complexity changes for the same problem. Let's say kth smallest element or largest element, whatever it is, equivalent.
yes.
Right.
Correct,
So
correct.
that I think is so we are kind of revisiting the same problem, but with a different data structure.
Different data structure. Yeah. So binary search actually we are using to reduce the height for the searching, reducing the time for searching. So and this data structure is also store the data in ordered way. So that is actually beneficial compared to the simple array or linked list.
Got it, sir.
So this is the last week problem, week 6. Now comes on the today first problem, week 8 problem. And actually week 8 is basically the main concept of the week 8 is divide and conquer. So the problems are also based on the that approach. divide and conquer approach. So first we will discuss the problem number 1. Can anyone tell me last open session how much part is covered?
Till points, right?
Week 8
Yes, sir. Till points.
points that
Using delta.
that part. Okay, closest pair of points.
Yeah, that recursive tree that is not taken. Others, I think, almost is covered.
Okay, okay. Recursion method for to identify the complexity that is not covered, no?
Yes, sir.
Okay. So this is week 8 problem number 1. Okay, so we in the next week, I think on 6th, your quiz 2 is scheduled. So before that, we will just schedule a revision session. So I think this time we will schedule 2 revision session. So in 2 revision session, we will cover 2 week in each. Okay, so 5th and 6th, and then other in 7th and 8th. Then we will cover the remaining part, if anything is remaining. Okay. So first, just quickly go through the problem statement and so write a function find median a comma b that accept two sorted lists a and b of the same size. Okay. And function return median of the sorted merge list of a and b. Write a solution of order. We go log n. Okay, log n solution. Now the definition of median is given here. So if length of the sorted merge list is odd, then median is the middle element. If the length of the sorted merge list is even, then median is average of two middle elements. So according to the problem statement, you will find out that the first statement is not useful for our problem. Okay,
Yeah,
but
because they
here,
are of both equal size. That's why.
yes. So here actually, if we give the odd size, still after merging you will get the even size. Okay, so after merging you will always get the even size. So, but for clarify the definition of median, just both statements are given. Okay, so now the problem is clear. So what we need to find out. But yeah, yes, so this problem you can easily do in the Python after simply merging the list, simply merge the list and sort the list, and then find, find out the middle two elements and just average. But actually that process will take at least n time. Correct?
That's the live solution.
N time I said that because already both lists are sorted. Okay, and if both lists are sorted, you can simply apply the merge process which you have used in the merge sort. Okay, simply compare the first element and then shift it to the correct position. Okay, so simply apply the merge process. So 2n steps are required maximum. So you can perform this, and you can find the middle element in constant time, and that means total order of n time is required. But how you can do these things in the better time complexity? Log n time. So here actually this approach divide and conquer comes to reduce the time complexity of this problem. Okay, so this binary search type of problems actually comes under this category divide and conquer type category. Otherwise, for binary search, actually we also use the another name divide and decrease. Okay, so but sometimes also called as the divide and conquer approach. So divide and decrease term is also used because every time we are just dividing the problem into a sub problems, and we are reducing the size of the sub problem. So because of that, this divide and decrease term is also used for this type of approach, where we are just reducing the size in the each sub after dividing. Okay, so now you can see how we can solve this using divide and conquer approach. Any idea? Anyone? No, you are not audible properly. Can you check your mic?
The maximum element of one array is
Mr. Siddharth, your voice is very low. I'm not able to listen properly.
hello.
Mm-hmm. Yes, now it is better.
We'll see if the largest value of one array is smaller than the smallest value of the second array, something like that.
Okay, then after that, uh, you are comparing the last element with the first element of the second.
Yes, yes.
Okay, and if I'm writing in the big font, so 1, 3, 5, 7, and 2, 4, 5, 8. So what happened when you are comparing this 7 and 2 then?
Hmm. Maybe we'll interchange or something like that.
Hmm. So in this way, can you reduce the problem size?
No, sir.
Okay. Anyone else? So I've already told you we can use the divide and conquer approach similar to this binary search way. We can reduce the problem size. So anytime when you are getting this log n time approach, so definitely you can think that how we can reduce the size half every time of the problem.
It's the
So
size
if
of
we
both the
split the
arrays, sir.
first list
Hmm.
at in the middle and second list on the middle,
Hmm.
and then we compare, let's say, the last three versus I think the second list would be either 4 or 5. Um,
Yeah, you are saying like this. So last three and first three.
Not that I was
So
actually thinking of dividing, splitting into, like when the
so
whole
this
idea of
time.
divide and conquer is every list has to be halved because we don't know where the median is. It could be on the first one or second one, right? So we don't know, right?
Yes.
So when we split, we are reducing the problem. Now the question is, we have to know which out of these 4 subparts, we have to only concentrate on the 2 parts,
Two parts. Yeah.
right? So it has to be either left or right on the first list and left or right on the second list. Now, under what condition we have to just figure that out.
Yes, correct. Yeah, so approach is nearly to correct. So we will doing the same things, but we will identify that which part actually we need to use in the next process. So after comparison. Okay. So yeah, this is correct because both lists are sorted. Okay. Then we can identify the middle element. So we can so here actually we have even numbers. So definitely if you use the length by 2. Okay, so here 4 is 2, and you can just simply use this formula. You are getting 2 index, and similarly you can get for the another list. Okay, and same things we will use the recursive approach. We can use the recursive approach for this uh, to pass the same problem with the half size. So every time initially the problem statement is given, both lists are same. both sides of the both lists are same. So definitely in the second iteration or second recursive call, our size should also be the same. Okay, so then we can follow the same logic again and again in the each part. So if we are dividing this 2 index, okay, so 2 index is coming at this 5. Okay, so at the time of even elements, so we have also think about that. If we are using this part here, okay, uh, then we have also used the 2 elements from the another list. Okay, so somehow we actually also maintain this middle element things with the even size and odd size. Suppose if we have odd number of element in the each list, then there is no problem. So like 1 3 5 7 9 and 2 4 6 8 10. Okay, then you are simply getting 5, this 2 and 2. Okay, you are getting these things, and similarly you are getting here. Now you can use 3 from here, you can use 3 from here, you can directly pick. So this time we are using the same middle element, but in the above case you have to maintain this thing, so you have to just change the middle element in one list. So if you are using 2 as a mid element for this list, so second list you have to use this 4 remainder 2 minus 1. Okay, so till this point. Okay, so this is the part of dividation, but before that we will identify the condition, what condition we can use for the recursive process, and what base case actually we can make. Okay, so you have to use the base case also uh, to stop the recursive call. So what is base, because every time we are reducing the size. Okay, so suppose after reducing the size, if we are getting only one element in both list, okay, like 2 and 3, we have only one element in the both lists. So this is A and this is B. So can we return the median directly?
Yes, the average of the two.
Hmm. If our n size, okay, so I'm here using this n size, and n equal to 1 in the both lists, so we can directly use the formula and we can add both elements, and we can just use this a0 plus b0 or n2. Okay, we can at any time when we are reaching this base case, when n equal to 1, we can directly use this formula to return median element. Another base case we can also make if we have two. Okay, if we have two elements, so because after reducing the input size by like 4 then 2 then 1, so every time we will either reach at the 2 first and 1. Okay, in that way. So if we have 3, then we divide by 2, then we will get 1. So like this. So our after reducing the size, we will always get either the one element size list and two elements. Okay, so in this two case, we can directly calculate the median element. So in the another case, if we are getting n equal to 2, okay, and both lists are sorted like 3 and 5, and another list is this is A and this is B, like 2 and 6. Okay, so in this case also we can directly calculate the median. Okay, uh, how we can calculate the median? We can simply pick the maximum of these two and minimum of these two. Okay, so maximum of a0 and b0. Okay, plus minimum of a1 and b1, and then 2. Okay, so after sorting these elements, okay, so you can see that 2 3 5 and 6, after merging these two lists, you will get this order. Okay, so that means you need to find out the maximum of these two elements. So maximum will come at this position, and minimum of these next two value, that minimum value will come at this place. Okay, and you need to find out these two value and then divide it by 2 after addition. So in the case of when we are reaching n equal to 2, then you can use directly this formula. Okay, So this is the case we can make as a base case. Now after that, how we can reduce the size for the remaining case. So n equal to 1 we have no, and n equal to 2 we know. Now we will check the remaining condition. So suppose one case like this, if we have element 1, 3, 5 and 6 and 7, and another list have like 2, 4, 5, 8, 9. Okay, so every time we will calculate the mid element, mid position, and we will compare the element. Okay, if we have size n equal to greater than 2, then we will follow this process. Every time we will identify the mid index. Okay, and after that we will simply compare the mid value. Okay, suppose if mid value are same, so this condition is actually useful if our list size is anything. Okay, so it may be 5, 6, 7 and anything. So if our mid elements are equal, so definitely, so actually you can see if both elements are equal, so the two value which are smaller than this, okay, in the first list, similar to two elements are smaller than this. So here we have 5 value which is similar, okay, and you can see 4 value we are getting on the left side. Okay, 4 elements we are getting on the left side because all are smaller than these 5 value. Similarly, these all 4 element will come on the right side after sorting. Okay, and after sorting, after merging, then sorting. So definitely these 4 element will also come on the right side. Okay, now always these 2 element will come in middle 5. Okay, so you can directly return the answer 5 plus 5 by 2. Okay, as a median element 5. This part is clear. If any time we are getting this condition, if our A mid, okay, is equal to B mid, so that definitely these two value will always come in between two index, and you can directly return the solution by average of these two values. Okay, so this is the one condition. Suppose we have now the two remaining condition we have only. So these 3 actually condition we can make as a base case. So here we are not calling recursively on any part. So if we are getting any one condition in out of these 3, so we can directly return the answer. But what happen if our A mid is greater than B mid, and if our A mid is smaller than B mid? So now these two remaining conditions are pending. So how we can approach the solution? So now these after comparison, so we can get these two conditions. So based on this condition, how we can identify that in the next iteration which area is actually useful to check, where our median elements can come. Okay. So we will identify the condition for this. So suppose I'm taking one the previous example like this. So 1, 2, 3, 5, 7, and 2, 4, 6, 8. Okay. So this is A, this is B. Now, first thing, here elements are not same. Okay, so all elements are distinct. So definitely middle element cannot be equal. So this type of situation. So now we in this case we are getting even number size. Okay, so definitely for the next process we will identify that. So if we calculate the median, so 4 divided by 2 we are getting 2 index. So we cannot use 2 in the both place. Okay, So here we are getting 2 here, 5, and here we are getting here. For the next iteration, actually we need the same size. So we have to just shift our mid value for the another second list B. So in B list, we will use mid minus 1. Okay, so we will use one index as a mid position. But in the odd size, we will use the same mid. Okay, so now after comparison, so here we are considering this as a mid. Okay, in the second list. Now we compare this 5 and 4. Okay, so A mid is greater than B mid. So this condition is true. Now just identify that if this condition is true, which part we need to check again. Okay, so what we can do, we can identify the situation and possibility. So we have total 4 element. After merging, we will get 8 elements. Okay, so we have total 8 position or 8 index. Okay, so I'm just marking the 8 index: 0, 1, 2, 3, 4, 5, 6, 7. Okay, so you can see first we are selecting this element as a middle element of the A. So definitely the with 2 elements are coming before this. Both elements are smaller than this. Okay. Okay, and also this 4 is also smaller compared to this 5. Okay, so definitely the which elements are coming before this 4 will also be the smaller of this 5. So we can simply identify this. These all 4 elements will come on this on the left side of this 5. Okay, so we can okay, so this condition we have identified that so 5. So I am not putting at the index this 5, but we know that 4 elements coming on this left part. Okay, this is 100% guaranteed, but it maybe increases. Okay, so maybe this 6 and 7. So this side, which elements are coming on the right side of this 4, that may also be smaller than this 5. Okay, so we cannot so minimum position, what is the minimum position of 5 is, so possible minimum position is 1, 2, 3, 4. So we can put 5 at this place. Okay, and this is the minimum possibility if we have only 4 elements which are smaller than this 5, and all the remaining elements are greater than 5. So our 5 will come at this 4th index. Okay, and definitely you can just conclude for this 7. So here 5, 7 is coming after 5. So definitely the 7 will be greater than 5. Okay, so we can simply conclude about this 7. 7 is definitely greater than 5. But we cannot conclude for this part. This is greater than or not. So 7 will definitely come on the right side of the 5 in this index. Okay, that means our 5, this is the minimum possible position for the 5, and the remaining 2 position are also possible. So 5 like this. Okay, so these 3 index are possible for the 5 value. Okay, so if our 5 is coming at the 4th index, so definitely the 7 will maybe come at the 5 or 6 or like this. Okay, so these 3 these position are possible for the 5. Okay, so this is the first thing. Now, so we can definitely talk about the 7. So 7 will definitely come after the 5, and we can also talk about this 2 value. So 2 and 4. So what is the possible? Okay, so finally after merging this sorted list, so definitely we need to identify these 2 element for the median. Okay, so 3rd and 4th. So we know that there is one possibility of this. We have calculated the possibility for 4, and what are the remaining possibility for another index? Okay, so this 2 element. Okay, so 2 element is guaranteed smaller than 4. Okay. Now, for third position, actually, we can figure out that how many elements can come. So four elements. This is the smaller part. Okay. So one thing. Okay. So this. Yes. So actually, in this area, definitely this 2 will come before 4. Okay, before 4. So if 4 is coming at this place, so 2 can come and in these three position. Okay, 2 can come in these three position. Okay, so this is the one situation, and also 1 3. Okay, so our range is actually, so 2 can come either 0 or 1 or 2. Okay, but not after that. Okay, 2 cannot come up at the 3 place. So this is the range actually we can identify it. So definitely you can see, so this 4 range. Okay, so this 4 element may become uh, the median. Okay, and also these 1 and 3 may become median in the next iteration. Okay, at the 3 place, because at this 3 place this 4 value can come, also this 1 and 3, these two position value can also come. Okay, suppose if I'm taking the order like this, so 1, if I change this 2 as a 1 and this 4 as a like 2. Okay, if I'm taking these two value as a 3 and 4. Okay, so these above two value can also come at this uh, this fourth third index. Okay, so because of that this 4 value can come, so this value, okay, so maybe come at this third index. Also the above value may come at this third index. So 4 1 3. Okay, but this 2 value will never come at the third index because this is smaller than this greater value. So this will definitely come before the third index. Okay, so in this part. So that means what part we can discard. Okay, so what part we can discard for the next process in this way. So that means we need to check this 1 3 5 from the first part. Okay, so in the 3 value. Okay, 1 3 5, and the lower value we can pick the last 3 value 4 6 8. This 2 we can definitely discard, and 7 we can definitely discard. Okay, and we can just choose this 1 3 5, or in the lower part we can choose this 4 6 8. So in this situation we will call the same recursive same function with the part of like a, and we will pass. So middle position was this 5. Okay, so we will pass the 0th 2 and mid. Okay, mid plus 1, like this. Okay, and for the b list we will pass like this. So b and mid to last. Okay, like this. So in this situation, so this is the part actually we need to identify. If our a mid is greater than b mid, so we will always select this first half. Okay, so including mid, the first half from the a list and second half from the b list. Okay, so if this condition is true, a mid is greater than b mid, we will select the part in this way: first half from the a and second half from the b. The opposite case, if a mid is smaller than b mid, so we will select the second half from the uh, first list and first half from the second list to the next iteration. So you can figure out the same things in the another condition. So you will get what element we can discard. Okay, so now we have all condition. You can simply write the solution in this cases, and you can see what are the condition actually. So we have base condition. If we have n equal to 1, we can directly return the average. If we have n equal to 2, then we can simply find out the maximum or then minimum, and then we can divide by 2. If our middle elements are same in the both list, we can directly return average of these two elements as a solution. And if we are getting a mid is greater than b mid, we will pick first half from the first list and second half from the second list. Opposite, if a mid is smaller than a b mid, then we will pick the second half from a list and first half from the b list in the recursive call. So these are two actually recursive call when we are getting a mid is greater than b mid or a mid is smaller than b mid. So in this case, just call the recursive algorithm and pass the index. So just use so do not use the slicing. Just write the recursive call without slicing. Okay, use the start index and last index for both list parameter. Any doubt in this logic?
So logic is simple. To arrive at the logic, that process is not.
Yeah, so that actually I said that in the initial part. So first two problems today is actually tricky. So because of that, I also explained the logic first without waiting the solution from your side. But after getting the logic, can you write the code?
Yes, sir.
So just try to
It's a
write the
struggle
code.
only, sir.
Sorry?
It's a struggle only, not easy.
Yeah, that problem is not easy. I already mentioned that. But after getting the logic, I have clarified the all steps. Okay, base case and recursive condition. Just write the code according to that.
So can you sum it up now again, because in between we just diverted for
Ha,
various other examples. Can you
So,
start to end single
so
flow without disturbance?
okay. So I just mentioned the base case first. Okay, so here input is actually two list, sorted list with the same size. Okay, and suppose if our input list size is 1. Okay, both list size is 1. That means both list contain only single elements. Then we can directly return the median by a0 plus b0. Okay, because we have only, after merging, we have only two elements. So the median will be the average of both elements. So we can directly return this solution. If we have two elements in both list, okay, a and b. Still, so this is the second base case we can make. In this case, if we have two elements in the both list, so we can simply identify the second and third element after merging. So how we can identify? We can simply identify the maximum of the first index element of the both list plus minimum of the second index of the index element of the both list. So definitely maximum of first two index element definitely will come at the second position, and minimum of the second index element of the both list will come on the third index. Okay, then we can calculate the average of both second index and third index. Okay, and after that, this is the second case. We can directly return the solution. And third case, I have just explained this. If our middle element, okay, so this is the two case. After that, we will compare the middle element of the both list. If we have a similar middle element in the both list, okay, so 5 5, so we can conclude this. So two elements from the first list and two elements from the second list, so both are all four are smaller than this common middle element. Okay, so four element can come at this first position, and these remaining right side two element of the both list definitely will be the greater than the common element. Okay, so these will come at the fourth place on the right side. So middle two position will remain for the this common elements, 5, 5. Okay, so 5, 5. Okay, so here in this case also you can directly return the answer simply by calculating this average of middle of both list. If both value are same, you can directly return the average of both. So this is the actually median of sorted merge list. Okay, so this is the third case, and the remaining two cases are actually where you need to reduce the size of next iteration. So these two conditions are remaining after comparison of the middle element. So based on these two conditions, I have just explained this, which part we need to pick for the next iteration. Okay, so if we are getting this A mid is greater than equal to B mid, okay, in the two list. So I have just explained this, which element we can directly discard. Okay, that will never come at this third index and fourth index, because here you can see we have 4 element in both list. So definitely after merging you will get 8 element. Okay, and we will, after sorting, we will pick only third index and fourth element for the average. Okay, so here actually we have figured out this. If we are getting this condition true, A mid is greater than B mid, so you can see that we can directly discard this 7 element, because this 7 element cannot come at this fourth index or third index. Okay, but the remaining position we are not sure. Okay, and the same things for this 2 part. This 2 will also cannot come at this third index, because there is one greater element 4 is also coming after this. So if 4 is coming at the third index, 2 will come on the left side. So definitely if any elements, so first 2 element from the first list or second element from the second list, so out of these 3 elements, any elements can come on this 1, 2, 3 position. Okay, so but this 2 element never come on this third position, so we can discard this also in the next process. So after discarding these 2 elements, we will use this size for the next iteration. So we will call the recursive same algorithm for this reduced part. Okay, so that means in this condition we are just taking the first half of the first list and second half of the second list. In the reverse condition, if A mid is smaller than B mid, then we will just pick the second half from the A list and first half from the second list. Okay, this is the reverse condition. We can simply just convert the replace the situation. Okay, and then we can figure out the same iteration. So we can directly reduce the size in that way in the next iterative or recursive call. So just use these 3 or 4 condition and just try to write the code. Okay, so this is the main function. Actually, we want to write the recursive call, and recursive call we want to also add some more parameter. Okay, so start index and last index for the both lists. So we cannot make this list as a recursive function, and we can simply call the another function from this list. Okay, so we can simply define the another list def, and you can give some name median. And here we can pass some parameters like a comma b, and I'm just giving the name. So sa, okay, sa comma la. Okay, so just understand this, sa comma la and sb comma lb. Okay, so start index for a list, last index for a list, start index for b list, and last index for b list. Okay, so I'm using these terms. So I'll call this from the main list. Okay. So I'm just making the return. So at the start index, we will pass 0. Initially, we will pass 0. And for the last index, we will use the length, len of A and -1. For the start index of B, we will use 0. And for the last index of B, we will use the len of B -1. Len of B and -1. Okay, so this parameter we have passed. Now we'll write the definition of mean, a recursive call, median. Okay, so first we will calculate the length of the input list. So how we can calculate the length? So n equal to LA. Okay, so we can calculate the length using any one list because we are passing the same size list every time. So LA minus SA and plus 1. Okay. And after that we can simply calculate the mid equal to n so division 2. Okay, but I mentioned that if we have in even size, so we have defined the mid element from the B in different way by reducing the one index. But if we have odd, then we will use the same mid value. Okay, so we will just take this condition if n percentile 2 equal to 0. That means if our size is even, then we will use. Okay, so we will use two more terms. Okay, so we can use mid of A equal to simply. So mid of A means S A plus mid. So this is the value of mid. And for mid B, we will use SB.
Sir, I have written the code, but I am getting two failed.
To error.
Two answers I am getting.
1 second. First thing is your voice is very low. Okay, let me open your code.
I have not submitted.
Siddharth.
Yes.
Okay, so len of A. Okay, so you are directly using. Okay, so len of A. Okay, so you are no. Calling this. Okay, you are using slicing. Okay, so let me check. So len of A equal to 1, len of A equal to 2, then return. Okay, in this way, fine. And max of A0 B0 and min of this is fine. And begin 0. What is this begin?
The start of the array and the end of the the index of the end of the array.
Okay. Okay, so and equal to len of A minus 1. And if len of A percentile 2 equal to 1. Once again 1 you are using?
It is odd. That is, it is odd.
Acha, okay. Len of A percentile 2 equal to 1. So mid 1 equal to mid 2 you are using begin plus end. Begin plus end. Okay. As mid 1 equal to begin plus end. Not plus 1, actually minus 1.
Should be -1, sir.
Yeah, mid 2 we are using -1. If you remember that, if we are using this as a 5 in the first, we are using 4 in the second, -1.
Okay.
Okay. And if A is equal to mid 2, then return A mid. Why this? Okay, so you are using A mid, actually use 1. L if A mid 1 is greater than equal to this, so find median A mid 1. Okay, 1 second. If A mid is greater than, we are picking the first part. Okay, so the first element to this mid element. No, no, no. So I think not correct. Mid 1. And also we have also include the mid element, so use the mid 1 plus. And for B list, use the second half, so use this mid 2. Okay. And the else part condition, just use the reverse condition like mid. Like this. Okay. Oh, failed. What difference is coming? (99.5) and 97.5. So some index difference is coming from somewhere. So we have to just figure out this. So 1 second. So in the remaining part, we have to pick the element from second part. Okay. Two element and two element from this side.
Sir, if I put +1, it is getting right. Now it is passing.
Okay, okay.
So
So
because
yeah.
if we are taking 3, suppose the length of the list is 4,
Mm-hmm.
and the index will be from 0 to 3.
Mm-hmm.
In the first list, the first element will be picked. That is the second element. That is 0. Element with index 1 will be picked. And in the second element, you have to pick the index with 2. You have to pick the element with index 2, right, sir?
Mm-hmm.
So you have to use +1.
Okay. Yeah, so this is fine. So based on the implementation, some index is changing from some way place. So if you are taking this +1, I think this is handling the condition. Otherwise, in the second condition, so this is actually because using slicing.
Slicing I have used only here, no, sir?
Uh, no, no. Actually, if you so this solution is actually not the login solution.
Okay.
Okay, using the slicing, this solution is not the login solution. This become a n order of n solution. So maybe this solution will not work on the portal if I think complexity is checking. Okay, so just so the logic is okay. Then you can also you can convert this logic into the without the slicing. Okay, use the parameters. then you have to change the logic someplace. Okay, otherwise logic is okay. So we are following the correct thing. We are just using the indexing part. So if mid 2, 1 second. If you are adding this begin plus end, 0 plus end, and then divide by 2. Okay, so that means you are getting the equal size in the both iteration. Just I want to quickly check this. So mid 1 plus, suppose if we have 0, this is odd, this is even. The case of even, mid 1 and mid 2. Okay, so using the first two. This is okay because you are taking this begin equal to 0, na? So 0 plus last index you are taking 3, then you are getting 1. But in my calculation, actually, I use the length. So yeah, based on the implementation, so this modification is okay. Yeah, this logic is fine.
But sir, how to modify for this? Suppose.
So if you want to write the code without slicing, then you have to pass the parameters of the starting index and last index for the both list.
Okay.
Okay, every time you have to define that what is what is the starting index and what is the last index we are using for the next iteration. Okay, and we are using the same list. We are just reading the elements from the specific part. Okay, according to this parameters value. Okay, so you can also you can see the binary search code without slicing. Just see how we are passing the parameter in the next iteration. So this is also similar. Okay, so you can write the code in this manner. Okay, here we are passing the same list. Okay, we are not changing the list. We are using the same list, but we are passing the start index and last index for both list. Okay. So you can simply use for the mid B also. Mid B. Mid, but if the size is even, then just update this mid by mid B minus 1. Okay, so this part is done. So now we will use the condition if n equal to 1, then return a0, not a0, sa. Okay, so we will also use the index in this manner, sa plus b sb, and then average. Elif n equal to 2. So return max of a sa comma sb. Okay, this is fine. BSB. Okay, and plus min of a uh, LA. Okay, so here we will use LA. So LA, comma, B, this is fine. Okay, divided by 2. Yeah, so this is the second condition we are using, and one more condition L if A mid. Okay, so A mid A equal to B mid B. Then in this case we will return. We can directly return. We can also return the average also, or we can return the value. So I think we are returning the solution in float every time. Yes, so we should use the float value. A mid. Plus A. Yes. Or otherwise we can return only one value. So this is the third condition. Now the remaining condition we will use the recursive. So elif if A mid of A is greater than B mid of A. In this case we will call the recursive. So return same median A comma B. Now we will pass the index. So the first half, so S A, and then the till mid A. Okay, and for the second list, okay, so this is the first half. Okay, so mid B to LB. So this is the call, and the remaining condition else return median A comma B. Second half from the so mid A to LA, comma first half from the second, so SB comma mid B. So this is the code. Yeah. So you can see the implementation without slicing here.
So essentially to visualize this, if I got a big length of things, we have basically two kind of pointers, right? One starting and ending, like some kind of, and then every time, every iteration, the width between these two, start and end, is actually reducing by half.
Yes.
And either the left hand side is reducing or the right hand side is reducing.
Yes, yes, yes.
Right? That's the, so basically what is happening, that's the kind of binary search, essentially. In the sense,
Yeah.
every time the number of elements in both the list is reducing by half, which is
Yes.
actually giving us the log n.
Yes, yes, correct.
Yeah.
And finally, we are reaching at the base case,
Base
either
case.
yeah, n equal to 1 or n equal to 2 in any these two cases.
So it's actually more complex than binary search. Binary search, at least it was very clear which side.
Yeah, yeah, correct.
Here it's like, you know, so that is where that condition is the tricky part. It was not clear. We knew it has to be halved, but how, where, you know, a lot of devil in the details.
Yes, yes. Okay, so in this approach, we are not using slicing, so we will get this log n time, and we can pass the test case on the portal if complexity we are checking. So also for the OPP exam, okay, so just remember these things. Don't use the slicing in the binary search problem. We have mentioned these things in many times. We have also mentioned on the GitHub notes. So actually what happened is sir is actually used the binary search with slicing in the lecture. So but the concept wise this is okay, but to achieve the time actually we need to ignore this slicing.
So because if you are slicing means you are not really like if I have a width of 200, when I make it 100, it's still searching to 200. It's a linear search from 200. So that's why there's no
Yeah,
efficiency.
we are simply making a copy
Yeah.
of the new list, and we are just reading the half of the element, and we are creating a new list, and we are just simple shifting the element in this list. So ny2 elements are shifting into the new list. So that is taking the ny2 steps. So because of that, it become order of n. Okay, so I hope this is clear for everyone. Next problem is also tricky compared to this one. Okay, more tricky. So I hope this is clear. Then we will move to the next.
So is this the peak of PDSA? I guess week 8 and then.
Yeah, you can say week 9 also, because in the dynamic programming you have to think more how you can just figure out the logic to convert into the dynamic programming
We're
approach.
thinking like the quiz one question. How do you know the uni model, right? The question. So it's like every week is looking like, still,
Yes, yes, yes.
it's like that.
Correct.
That's what I'm saying. When we see Li plus 1 is, less than Li, then okay, we can breathe.
Yeah. So for OPP exam, just focus the graph algorithms for one person. I mentioned these things. Okay, so you should know how to use binary search. You how to perform the operation on linked list. Okay, and dynamic programming, basic idea, and some binary search operation like this, basic operations to traverse the binary search tree and heap, like this basic operation. Not this type of problem actually we generally not ask. So here the logic finding is actually difficult.
This kind of questions can be graded, but not like OPP. OPP is like.
Yeah, we know that there is a extra pressure of the time time pressure. So we generally gives the very similar problem which you have already seen someplace in the content. Okay, so now move to the next one, and that is also a similar type, but logic we will just figure out. Okay, so write a function kth element a comma b comma k that accept two sorted lists a and b. Okay, so similar to previous one, but this time size is different. Okay, so n and m respectively, and a integer value k. Then function return kth element in the sorted merge list. Okay, so kth element from the start. Okay, kth element in the sorted merge list A and B from start. Write a solution of order log n plus log n. Simple thing. This we can also using the naive approach after merging the solution and sort the list. Okay, and then find out the third element from the start. So in that way, you can use this, solve this using order of n, in the order of n time. But how you can improve this? So this is not easy compared to the previous one. Okay, so some similar, we will approach in the similar way. Okay, but this time the size is actually different. Okay, of the both list.
So the equivalence we see is, obviously previous one, the kth element was essentially n plus m by 2 rank, essentially like an equivalent of median. Instead of median, you're finding k,
Kth.
and here
But
we
also
still,
size is different of the
yeah,
both.
size is different because there's a log. That means even if they are different, every time both the lists have to be halved. Only then we will achieve log. That is
No,
for
no.
sure.
This time the complexity is asking log n plus log m.
Yeah, that's the. I think
Okay,
if
so
we
no need to halve the both. You can just reduce the size by half any one every time. But we will think in the similar way. So after just comparing the middle element, then where our kth element can come, so which part we need to, which part we can reduce in the next iteration from which list. So in this problem actually we cannot discard the both by the half, but we can discard one list by the half.
So if the first element is n size n, and let's say a is of size n and b is of size m, right?
Hmm.
And we know both are sorted, right?
Hmm.
So if our we find n by 2 and m by 2,
Hmm.
and we compare,
Hmm.
let's assume they are all in ascending order, and we are finding the kth element, whatever it is in that order.
But here actually size is the main problem, na? So size of the first list may be large, or maybe second list of the list is large. So we don't know these things.
Yeah, that's right. And in fact, it is possible that the lowest element in the second list
Hmm.
could be higher than the largest element in the
Yes,
first list.
yes,
It's also
yeah,
possible. That's
yeah,
like an extreme case, right?
yeah, correct.
And the k could be less than m by 2. So that means it's itself is in first list.
Yeah, correct.
Yeah, those are all extreme cases, but yeah, that is also possible.
Hmm. So here we can think about we are reducing the size of the one list every time by the half. So at any time we will reach at the situation when any one list have only one element. Okay, so either the first list or second list, the size is reached at the one of any one list. So after that, you can identify the kth element or not in this situation. So some base case you can design in this manner. So suppose some situation. So if one list, have only one element like 5, okay, and second list have like 2, 3, 8, 9, 10, 5 element, okay. So in this case, suppose I'm taking n equal to 1 for the A list. This is A and this is B. So here m equal to 1, 2, 3, 4, 5. Okay. So suppose if we are asking k equal to 1, can we identify this k equal to 1 in this case?
Yeah, A0, B0, minimum that.
Simple, na? So we can simply return min of A0 and B0. Definitely the one element of these will come at the first position after merging. So we can return the solution directly in this situation. The same things if we ask, so what kth value is the possible to ask, okay. So here actually we have 1, 2, 3, 4, 5, 6, okay. So that means we can ask k equal to 6. We cannot ask after that because we have only this time 6 elements. So we can ask either first, second, third, fourth, fifth, sixth. So this is the maximum. So can we identify the max element?
Yeah, max of A0, B0. I mean BAN and BN, whatever.
So we can
Minus 1,
simply
minus 1. A minus 1,
yeah,
B minus 1.
max of A0 and B of m minus 1, last element. Simply compare this and this element, both which is greater, that will come at the last position. So this is the one possible case. If this is the situation, okay, so either n equal to 1 or m equal to 1, we can identify these two cases, okay. So k equal to 1 and k, or we can write this in the manner, so we cannot write 6 like, so we can write if k equal to n plus m, okay. If k equal to 1, we can identify if k equal to n plus m, that means last position. So we can identify in here also if any value equal to 1, okay. So either n equal to 1 or m equal to 1, so we can figure out this. If in the case of m equal to 1, so either you can use the both condition. In the base case, you can apply the same logic for the n equal to 1 and m equal to more than 1, and in the else condition you can change the condition if m equal to 1 and n is greater than 1. So you can make this type of situation as the base case, okay. So this is for the, or any other position can we identify in between?
So if I take the max of, I mean, assuming now it's not the 1 or whatever, right? It's kind of any size, right? Random size. If we take the last element of A and first element of B, if we compare, and let's say, I mean, that's again a kind of extreme case. And if any one of is higher or lower, right? So we will know that there is what I call as stochastic dominance. Like, one of the, I mean, all elements of a list is completely greater than the other ones. So there, the rank of, either n or n plus 1 or whatever can be identified. But again, that's a rare situation, but it can be done.
So just take simple example. Just can we identify k equal to 2 by any simple constant logic?
So that is possible when both the lists are one element each, or 0 and 2 also is possible. Empty list and 1 is easy, but
So just think about this. If we are asking k equal to 2, okay, so that means after merging, we are interested to identify the index which is coming at the second. So index is actually starting from 0, 1, 2, 3, 4, 5 like this. Okay, so for this example, we have after merging we have 6 element. Okay, and we want to find out the second element from the start. So definitely one of the element for if we find out this minimum element, okay, so one element definitely will come at this position. Correct?
That is the minimum of A0, B0.
So definitely in either 2 or 5, any one element will come at this position, and of this 5 or 3, so this is the counter position. So maybe 5, this element can come. Sorry, this 5 will come. Okay, so yeah. Okay, so yeah, so we have to figure out this. What are the possibility for second index? Okay, so at second index, if we compare the first element, okay, so this element with this second element, okay, because we are asking this k equal to 2. So if we compare the second element of the B list with the first element, okay, so definitely one element which are coming, so either there is a chance, so this may be the smaller than this 5, okay, so then this 3 will come at the second position.
So that means that when we are comparing the first position, it is minimum of A0, B0, right?
Mm-hmm.
So that is fixed. That is basically the smallest. When we are talking about 2, depending on what the result was in the first comparison, right? Either the first element or second element sat there, right? If you know which one is smaller, that means you have to take, if A0 was smaller, then you have to ignore that. If B0 was smaller, then you have to compare A0 with the next element of its counterpart. So here, in this example, 5 to 3. So because 2 was smaller than 5, 2 takes the index 0.
First position,
So now we
yes.
compare the A1 with B1. I mean A0 with B1. But if reverse was the case, let's say first element in B is smaller compared to the A, then we take the smallest element in A and compare it to next element in B.
Yeah,
One.
so this is the one particular case for the first situation. Suppose we can ask k equal to 3, k equal to 4 like this.
Right.
So how we can make the common condition? So for this situation, so because of that, if we are comparing these elements, okay, so definitely the one element which are coming before this, so definitely it is a smaller element compared to this 3. Okay, so definitely when 3 is coming, 2 will definitely come before this. Okay, but there is a chance, so this 3 can come at the second place, or this 5 can come either of 0 place or this place. So two condition are possible. So suppose if this value is smaller, okay, so if I'm comparing, if I'm writing this index, so I'm just taking the condition if uh, so this time we are taking B. Okay, so B k value we are taking 2, but I want to check the second position, so I will use the index k, so k equal to 2. Okay, 2. So this is 0 part. Okay. Okay, so we want to find out the second position. Sorry, what condition we can make? So if I write this k minus 1, if it is smaller than of a0, or still not able to identify the exact situation, bk minus 1 is less than or equal to a0. So in this situation, if this is smaller than a0, so definitely this will come at the pth value. So
So
can
in
we,
that case, you can return the minimum of A0 and Bk. That will be the kth smallest. Because Bk minus 1 elements are all less than Bk. We know that. So if all these k minus 1 are less than A0, then the only element which will take kth position will be the minimum of A0 or Bk. This is a special case.
so in this situation, just tell me if I'm taking bk minus 1 is less than or equal to a0.
Yeah.
So definitely this 5 will come after this 3.
Yeah.
So definitely we can directly return this element as a second element.
Yeah.
Correct. So we can return like this, return this bk minus 1 like this.
So not straightforward, because what if we can always create a case where A0 is actually smaller than Bk, but greater than all preceding elements, k minus 1 elements of the list. That's also possible. So
That will
technically,
we will make the other condition. So but in this case, can we return the
yeah,
direct
yeah,
answer?
yes.
Okay, so if we are asking k equal to 3 and our first element is greater than this 3, then we can return the 3 as the answer, 3 index as the answer. What are the another condition? If so, the remaining case is equal to case or opposite. Okay, so if our b k minus 1 is greater than or equal to a0. So in this case, what we will return? So just think, if our in this case, if of this 5 element is smaller than 3 or equal to 3, so in this case, what element can come? At this position. So okay, so we are checking third, if our smaller than,
In
if
this
it is,
case, how is it going to be? I mean, I think if you actually do the reverse, which is all the
so
elements in AK minus 1 is actually greater than B0, then it will kind of, we can skip or eliminate K position. So
one thing we can do, we if this condition is true, okay, so what we can do, we can simply find out the min
So
of
for such problems, right, like how they taught, like divide and conquer type, use merge sort, you divide it and find, that is what is taught, right? We cannot use
yes, we are
such
using divide and conquer approach in this problem, but we are figuring out the base case, because if we are dividing the problem into the size, then we have to reach at the base case, and in that case we will return the answer directly. So first we are just simply figuring out the base case.
Okay, sir.
Okay, so
It's so difficult to figure out the base case.
yeah, so this problem is not that much easy. So yeah, so I've just now we have already covered now. So this case, okay, so this is the case if our bk element, okay, so bk minus 1, sorry, bk minus 1 element is greater than or equal to a0, can we return the min of bk minus 2 K minus 1 is this, and K minus 2, yeah. B K minus 2. Okay. And A0.
K plus 1. If you use K plus 1, then it will be correct.
K plus 1? No, if I am asking K equal to 2, okay, then we are just comparing this this element 3 with 5. Suppose this 5 is coming at the like 1. This is a 1. In this case, this 1 is smaller than 3. What we are trying to do, we are just moving to back in this position, and okay, so definitely we are finding out the minimum. So what we are returning, actually K equal to 2. Okay. So we cannot return the min here. Max. Can we return max? So first or this last element. If we return the max element, so that will come at the second position. Okay, I'm writing the different example. Just think about this. So if a list is like so 3, okay, and B list is like 2, 4, 5, 6, 8. Okay, so if I'm just saying that K equal to 3, I'm asking K equal to 3. So what we will do, so this actually a list. So for finding the third element, we will simply compare by the second index. So because of that, I'm comparing if B K minus 1. Okay, if B K minus 1 is lesser than what condition was we are taking that in the previous? Okay, not lesser. So this greater than or equal to A0. So in this case, if this condition is coming, so you can see that A0 is smaller than this Kth value. Okay, so this K minus 1, that means third position but second index. Okay, if this situation is coming, can we compare these two elements and finding out the max? So max of B K minus 2 is K minus 2 and A0. So maximum element of these two elements will definitely come at the third place.
Yeah, when actually one of the list is one element, other one is yeah, that's because it's uneven, right? So one of the list base case will be when one of the list will get reduced to one element. That is
Yes. So
whatever.
this case we are considering it for the
Right.
all base condition. Okay, so if we have one element in the one list and if we have a more element in the another list, so can we identify the kth position or not in the constant time? So we have already seen that we can identify the first position easily. We can identify the n plus m position also, and we can also identify the middle position. Okay, so if k equal to 2, we can apply this logic. So simply compare the first element of the A list, so only one element, and the k minus 1 index. Simply compare these two, and based on the condition greater than or equal to, just figure out that which element can come at the third position or it's like. So we have defined both the condition. If this condition is true, we will read this element, we will return this element as the answer. If the opposite condition is true, then we have marked the another condition, this return Bk minus 1. Okay, so both condition we have figured out this. So that means if any list is reaching at the one element, we can return kth element in the constant time. So this is the main base case. After that, we will simple apply the mid comparison. Okay, so base part is clear.
Yes, sir.
Okay, now come to the remaining part. If we have the greater size, so for the greater size, simply we will calculate the midpoint for the both. Okay, so mid one for the first list. So we can simply take n minus 1 divided by 2, or mid 2 for the second list. So here size is different actually. So we will calculate the mid for the both separately, like this. Okay, so this is the way to calculate the mid one and mid 2.
n minus 1, no sir.
N minus 1. This is m minus 1.
n minus 2 you have written.
Sorry, 1. Yeah, correct. Okay. So this is the mid calculation. Then we will compare. Then we will check if our k. Yeah, so this part is actually tricky. So k is greater than mid 1 plus mid 2 plus 1. So this is one condition. If our k is greater than mid 1 plus mid 2 plus 1. Okay, so this situation. Here actually we have to take some situation. So mid 1 plus mid 2, and our k is greater than this value. And then we will compare our mid element from the both list, and then we can figure out what part we can reduce. Let's take some example now. So this will not be clear by this.
So here you can skip the first list intuitively because, because K is more likely to be on the second list. You can skip the first list in this case.
So that one part we can reduce in this situation. So also this is the one case when we are taking this condition, and we will also take the else part. So that means we will check the both condition. So inside this condition we will check if a of mid is greater than b of mid. Okay, so this is mid 1 mid 2, this situation, and the else part. Okay, else part, and the else part for this, and we will check the both condition for the else part also, and based on that we will call the recursive approach. Now just figure out that what part we can remove based on this condition. So suppose I'm taking some elements now. So like reading the test case. So 1357. Oh, this is also similar. Okay, so 1357, and another list is 2458. Okay, so 2458. So now both lists have greater than one element, so we cannot directly apply the base case. So we have to come this condition. So first we will find out the mid one for the first list. Okay, so this is the n is equal to the length of the first list. So n minus 1 3 and divided by 2, and we are getting 1. Okay, similar for the second list, we are getting 1 index. So 3 floor division 2, we are getting 1. So based on this situation, suppose if our k value after merging, if our k value is like 4. Okay, so then we are asking the fourth element. Okay, so now this condition is true, k equal to 4, and then mid 1 plus mid 2 plus 1 is, this is 3. So this is true. And what is the mid element? Actually this one and this one. Now can we figure out the part which we can remove in this situation? We are asking, after merging, we are asking that k fourth element from the starting. So we are comparing this two element. So this is 3 actually, and this is 4. So this is coming at the else part. Okay. So for the else part, if you see that this value is actually smaller than the B mid. Okay. So this is B and this is A. So A mid is actually smaller than the B mid. Correct? So definitely you can say if this A mid is smaller than B mid, so definitely these both two element and this one element will come at the before. Okay, so this 1, 3 and 2. These three element at least will come before the 4. So these are the three. But these can also become before, because we are not sure about this, but this is the three element definitely come before 4. So our position of the 4 is at least minimum possibility is the 0, 1, 2, 3 index. Okay, so this is the third index where the 4 can come at least. Okay, and you can see this two element will always come after the 4. Okay, so two element will always come on the right side, but we are not sure where these two elements can come. So the position, so what are the total elements after merging? 8. Okay, so index are 0, 1, 2, 3, 4, 5, 6, 7. Okay, so you can see these two elements which are coming after 4 in the second list will definitely come on the right side. So the position of the 4 maybe occur in 3, 4, 5 in these three index. Okay, okay, so this 4 cannot become before this and cannot become after 5 index. So in these three position, this 4 value can come. Okay, so what part you can remove in this? So you can remove this 1 and 3 part. This 1 and 3 part you can directly remove, because these two value definitely will come before the k value. So we are asking k equal to 4. Okay, so you can see we can directly remove this. So 4 position is this. So definitely 4 is coming at the 3 index. So the remaining value, so this 1 and 3 will also come at the before this. So definitely it cannot be come at the 4 place. Okay, so this 1 and 3. So this 1 and 3 cannot be come at the 4th place which we are asking. Okay, k equal to 4. So we can ignore this part completely from the next iteration. We can simply pass this half and this complete in the next iteration.
The recurrence relation would be Tn equal to 6 by 8n in this case.
How? So here actually we will add the recurrence like this. So no, actually we are not sure what list we are reducing, but every time we will reduce half of the one list.
Got it. So minimum
Okay.
of whatever. Yeah. Got it.
So either the A half or either the B half, we can definitely reduce based on this information. So this is the case of the else part. Here we can pass the next iteration. We can pass A mid plus 1. Okay, so mid plus 1 to last. Okay, so this is the last element. And complete B list. We can pass this part. Okay, and the reverse case, if A mid is greater than B, so we will get the different situation. Okay, so this is the case. Yeah.
So coming to that order, m plus n is like what? Like log of mn basically, right? Log m of. So that means if I have got m elements in A and n elements in B, they can be arranged. I guess all the elements in A will remain in A, but they can be arrange them. So we have to think like, how by reducing any one of the list by half, we are actually getting that log mn or log n plus log n. That
Yes, log n plus log n. Yeah, correct.
yeah.
Okay, so this is the one case I have discussed. If you take this situations, okay, A mid is greater than B mid. So you can think about one example. So like I just write the reverse order. Okay, so 2, 4, 5, 8. Okay, so now this is the A list and this is the B list. So 1, 3, and like what are the elements? Or we can write again any. So 6, 7. Okay. So in this case, suppose this is the A now and this is B, and we are finding the middle element this one and middle element this one. Okay. So now you can see in this situation, this 4 is greater than this 3. So definitely these two elements are smaller than this 4. Okay, and this is also smaller compared to this 4. Okay, so these 3 elements will definitely come on the left side of the 4. Okay, so these 3 elements will come on the left side. Okay, so 1 or 3 or 2 like this. Okay, so but these can also be come before this 4 element. Okay, so because of that we cannot discard this element as the 4th position. Okay, so because at the 4th position this 6 and this element can also become, because if we have value like this, so 1, 2, 2, 2. Okay, so now you can see that this 4 is greater than 2, but you can see all 2 are coming are smaller than this 4. So after merging, these all 4 will come before this 4. So because of that we are not sure about this right part. Okay, and we can definitely ignore this part because this will definitely come before the 4. Okay, so and also, so this time we can reduce B half and we can take the complete this one. Okay, just reverse condition of the above situation. Okay, so we can use this two situation inside this condition. A if k is greater than mid 1 plus mid 2 plus 1. Else part if k is smaller than or equal to this value, then we can discard the greater part. Okay, so what is the else part is if k is greater than, if k is smaller than, okay, smaller than or greater than, sorry, yeah, smaller than or equal to mid 1 plus mid 2 plus 1. Okay, so if k is smaller than, okay, so if I'm taking the same situation for this previous example, so a equal to now 2, 4, 5, 8. Okay, and b equal to 1, 3, 6, 7. Okay, so what are the possible value for k is less than equal to? So this is 1, this is 1, this is 1, 3. Okay, so that means we can take k equal to 1, 2, or 3. These 3 value are possible for this condition satisfaction. Okay, so in this case, if I am just comparing these two elements as a middle element, then what part we can discard for these 3 value? Okay, so here you can see if this 4 is greater than 3. Okay, so 4 is greater than 3, definitely these two value and this one value will come on the left side. Okay, so these 3 value come on the left side, now 4, and these two value will be come on the right side. Okay, this part, okay, so 5 or 8, because this is greater than 4. Okay, but we are not sure about this part. Okay, so these 5 and 8 cannot be come before 4, because we are asking only 1, 2, and third position, and the minimum possible position for the 4 is 4. Okay, so that means we are interested for 0, 1, and 2, this position. Okay, so first, second, and third, so these are 3 position we are actually want to identify. So that means which elements are coming after this 4. So this 5 and 8 we can discard for the next iteration. So this part we can discard for the next iteration, so we can just take this and this complete, like, okay. So this part we discarded for this iteration. Okay, similar to the another position, if our the b element is greater than then we will discard the b greater half and we will pick the a complete. So these are the condition we will use as a recursive approach after writing the base case. Okay, so this part is clear. Base case and this recursive call part is clear, or we can write the code also. One second. Anyone have written something in the code?
Again, we have to pass the this only, no sir, indexes only, no?
Have you written something?
No sir.
Not okay. So, quickly, I'm writing the solution. So, the third problem is very easy. So, I think that is no need to. That will not take time, and you can also solve that. That is a simple Python-based problem. But this problem actually we can discuss. Uh, so, so here actually we need to write this function kth element f, and inside this function, so we will use the recursive things inside this also. And okay, so this time we have two list, same thing. So we have to write okay. So we are calling the recursive function, so return like kth and a comma b, and k we will also pass because we are asking the k value. And before that we can write l, this is the same things as a comma la and sb comma lb and k. Okay, and now we will write the df kth. So we will use this. Okay, so first we will write the base case. Now first we will calculate the n or m value. So we will calculate the n like using this L of a minus s a plus 1, similar to m equal to L b minus s b plus 1. Okay, these are two value. Now we will use the base case. So if our n equal to 1 or m equal to 1, so we will use the both condition if n equal to 1. Okay, if our n equal to 1, so we will write the code according to this. So we will write like return sorry, inside this we will take this condition if k equal to 1. So we will directly return the solution. Return min of a as a, so n we are using the a list. Okay, so s a comma B
SB.
S B. So this is the first case. If and another condition elif k equal to n plus n. In this condition, return a as a and maximum. Okay, so max of SA plus B m minus 1. Second case, L else.
Would that be B n minus 1 or B?
No, B, we are using M now.
Oh, yeah, okay, yeah. Sorry about that, yeah. Please carry on, yeah.
So in the next condition, if what condition we have taken for the next base case? Yeah, so the first the condition is this: bk minus 1 is less than a0. If b k minus 1 is less than 0, sorry, a is 0, s a. Okay, and what we will return in this situation, what we are returning a second. So return bk minus 1. Okay, bk minus is less than a0, so we will return that. Yeah, okay, this is fine. Return bk minus 1. Else part, we will return max of b k minus 2 and a s a. Okay, this is the case which we have discussed. Bk minus greater than, then we are returning max of bk minus 2 and a0. So this is the base case, and the similar base case we have to return if m equal to 1. Okay, so if m equal to 1, that means
Just switch A and B. That's the easy way to do it.
also we have to pass the reference index. So min SA and SV is fine, I think. First case, if k equal to n plus 1, then we will just use this. Okay, so here n minus 1 and here SB. Okay, so here actually we have to write the A, and this is B.
Instead of SP, we can write 0 also, no, sir?
So 0, no, we are not passing the 0 index every time. We are passing the parameter. Okay, we are not using the copy of list. We are using the same list, but we are identifying the first element using this parameter. So B, and return the A. Else part we will write A, and here B, SB. Okay, so I think this is okay. So this is the base case. Actually, we have written 2 times, and after that, so we are writing inside the function. So we have to start from here. So now we will calculate the made point. So made 1 equal to n minus 1 or 2. Made 2 equal to m minus 1. 2, and then we can take condition if not here, if k is greater than equal to made 1 plus made 2 plus 1. Then we will write the condition if A mid 1 is smaller B mid 2. Then this situation, now what part we are discarding? If A mid 1 is smaller than B mid 2. So where is that part? In this situation. So in this situation, we are discarding A half, first half. Okay, so we will just take the element A mid 1 plus 1 to last. So we will write. So we'll call the same a return kth, and we will pass A comma B and comma. So the for the first list we will discard the half part. Okay, so that means mid 1 plus 1. Okay, this is the starting point of the A list, and the end point will remain same. So LA, and second list will remain completely same. So SB and LB. Okay, this is the list. I think we are missing something. Should we change this K value? I think.
Yes, sir. K minus.
Because we are discarding the some elements. Okay, so we know that this 1 or 3 actually we are discarding, but definitely it will come in the initial part. Okay, and we want to identify the kth element in the next iteration. So we have also reduced this size from our K. Okay, suppose we are asking K equal to 4, and then after discarding this 1 and 3, we are remaining this 2, 4, 5, 8 and 5, 7. So, but after merging this two list A and B, this 1 and 3 will also come at the initial part. So that will also take 2 position. Okay, and if we want to identify the K equal to 4, so we have also include this in the counting. So in the next iteration, we will reduce our K by this 2 size. Okay, what size we are discarding, that part we will actually reduce. So in the next iteration, we will find out the second element.
So this will be K minus mid 1.
Sorry, K minus
Mid 1.
Mid 1 plus 1.
Mid 1 or mid 1? Yeah, mid 1.
So size, yeah, K minus
Mid 1
mid 1 plus 1, no?
minus 1.
Minus 1.
Minus 1, because we are eliminating mid 1
Yeah,
plus
yeah.
one element, right? 0 to
Minus 1.
minus 1. Yeah. Yeah. So this is the tricky part. So basically, if you are finding fifth largest element in the original question, then if we eliminate 2, then the sub problem will be find the third largest
element.
Right.
Yes,
Yeah,
the
that's
remaining
basically
elements.
correct. Yeah.
And so this is the one, and the else part for this will in the same. But this time we will discard the B first part. Okay, B first part. So A bid, so this will remain same. So S A and L A. Now this will become mid 2. Mid 2 plus 1. And this will become K minus mid 2 minus 1. Okay. So S. So this is the one part, and the remaining condition else part for this. Okay, so we will also write the similar definition, but we will change the discard things. This time we will not reduce the K. Okay, because this time we are discarding the larger part and K value is smaller. So in this call, we will not reduce our k value. So what we are discarding in this case? One second.
LA will be
So if our a mid is greater, then we are discarding the second part, mid plus. So we will just read the SA to mid. For what condition we are taking? I have written something. A mid one second.
LA should be mid one, right? Not SA. We are updating LA if that is the situation.
If this part is okay, 3 and this is 4, okay, less condition. Okay, so similar to this one. So if A mid is smaller than, then we will discard the B half, second half. Right? So this is the situation when A mid is greater than, then we are discarding A B. So what is the reverse condition will be? So A mid. I'm also confused. So A mid is, so now B mid. Okay, so now we will discard the mid of second half of the mid. So A B mid, this is fine, and L A not L. So this part will remain S A. L A, but this will become mid. No. Second half S B to mid. And we will not update the K this time. And in the another condition, we will discard the, so S this time, yeah. So we will take S mid one and will remain same as B. And okay, so I hope I have written the code.
So these are the 4 conditions. So, if we look at the pointers, right, think about like search space, right?
Mhm.
We're saying what is the starting of A and what is the last of A, right? SALA. And similarly, we have SBLB. So depending on the condition, either we are moving SA to the left or LA to the left, basically like that.
Yes. So in the case of when K is smaller than or equal to our mid 1 plus mid 2, then at that time we are discarding the larger part of the one list. And at that time there is no need to update K value, because we are discarding the part which are coming after that K value. So no need to update. But in the above part, actually we are reducing K according to our value. And what is red message coming? SA. Oh, okay. So 0, 0, lamp of A minus 1, 0, and the value is passing. Okay, fine. Let me check. I don't know. Maybe something. Fail pass. Okay. So what difference is coming? 34. Expect. Okay, so this is for pass one. Sorry. 9 and 5. Okay.
It should show the list AB, otherwise it's difficult to interpret the results.
No, it will also show. So you can see this is the big list. So 10th element after merging. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is coming at the 10th position. Yeah, answer is okay, but what our solution is returning, this is 5. Okay, so maybe some error is happening.
I think it's the accounting that +1 -1 because it looks like that edge case when we are moving because we have 4 pointers, right? So that mid -1, mid +1, that last on the line 30 and 32, we have to think through 32.
Yes. So bit 2. So what things we are not doing correct? So in this case, a mid -1 with this, we are just using the SALA in this situation. Okay, this is okay. Okay, so now this is the debug part actually. Is the mistake. So this discarding part we have to check first. So mid one, or we have to debug. So this is the input. Okay, and we will check when our solution is returning. So we'll pass some area, return. Okay, pass like this. What value we are getting? Then what is SA, comma A S B B. Okay. Oh, the size is very.
Very large size array. That's why it is going through multiple calls.
But when I enter, so I'm getting this indexing 099, 099, 10 in the initial, then 099 second is reduced 049, and 049, 049, 049, and we are reducing continuously. 12, 12, okay, then 12, 6. So B list is actually reduced by 6, and then 6, 6. Okay, so answer will come in the first 6 element, 10. Now, okay, so this is the thing from here. 0606. Now 46. So first half is reduced by the A. So what is the A list? Okay, let me write some value in the initial part. So A list is 0, 2, 4, 6, 8, 10. Or this is 1, 3, 5, and 7, 9, 11. So these are 6 elements now we have. So in this case, we are getting 4, 6 index from the A list and 0, 6 from the 6. Okay, 4, 6. So indexing is 0, 1, 2, 3, 4, 5. Why we are getting the 6 index? 6 index, we have to take one more element. 12 and 13. Okay, this way. Now 4 to 6. We are taking like this part and complete the second list. This one. Okay. And next iteration 2, 6. 06 06 46 06 26 26 is not looking correct.
It's eliminating from the A list. That's why the SA is moving to the right.
No, but we have taken the index 4 to 6. Then how 2 can come again in this part?
Oh, yeah, it's going back. Yeah, that's correct. It should always move to the right.
Right, yeah.
Yeah, it's kind of going in the river. Yeah, that's correct. So that is where we have to look at the SA logic, basically, sir.
Let's see. Where we are reducing the SA size actually.
Yeah, should not happen.
Okay. So if we compare the mid element in this part, okay, so now we have 4 to 6 this range. Now if we calculate the length, n, what is the n? Is 6 minus 4 plus 1. So 6 minus 4 is 2 plus 1 3, and okay, I think 6 minus 4. Then n size. Okay, so n size is okay. So 3 and divided by 2. So we are getting 1, mid 1 equal to 1. Okay, so 1. Yes. So now the next half part should be is either 4 5 or 5 6, I think. But how it become 2 6? So that part. If we compare the mid element, this 10 should be compared with 7. So how we are calculating the mid y like this: 3 minus 1 by 2. So still we are getting 1, and the remaining we are getting total 1 to 7 elements. 7 minus 1, 6 divided by 2, 3. 3 is this one. So you can see the mid element of this 10 is greater than 7. So in the big case, this now k we are asking 10. Okay, and 10. Okay, so mid is 1, and in the another list mid is 3. So 3 plus, yeah, k is greater than. This condition is true. But now a mid is greater than a mid 2. This condition is true. The now kth value we are using mid 1 plus 1.
Sir, we forgot to reverse the order in line 35. It should be greater than, right?
Line number?
In copy pasted, A mid 1 less than B mid 2. We forgot to reverse. Less than should be greater than.
This part?
Yeah, isn't it?
No, this should remain same, no? In the both condition we are using the both.
Okay.
But here AB mid 1 plus 1. Okay, so I think this should be S A plus S is the first index, then mid, and we are adding mid, and so are we getting correct? We are discarding the first half, mid plus 1. I think this is okay, and similar thing we will do for the remaining one, the B part. Similar SB plus S capital B. And what happened? And here also we are passing mid. So this SB and mid 2 and SB plus mid, and this become SA. SA plus mid. because we are calculating this mid one and mid two by the length, total length. But in the actual implementation, this should be updated, not the one or two like this. So position should be correct. Okay, let me check again. Oh, now passed. Okay.
So again, to avoid the slicing, we have to do.
Still one test case is failed. Okay. And what? Oh, actual output is. Oh, what output is coming? We have print something in this.
The list is 5,000 list.
Oh, okay. I think we have print inside something.
Yeah. That's why.
Let me check. Not passed. Once again, still not correct. Input output no for this one. 9 and 7 still some indexing issue is there. Okay, again once we have to check what is wrong. A mid one. Okay, 1 second. SA plus PSP. SA plus SP plus. I think this is okay. No one is failed. Where? Oh, we still have everything else. SA and SV. This is fine. SA equal to SP equal to mid 2. So this S equal to mid is less than equal to SP equal to mid 2. Then SP is now we have to both once again. Yes. Yeah. Oh my god. What is very weak. Start. Okay, it will take some time. Actually, output is input is very big. This case. So we have to manually apply the dry run some input. Then we have to check for some small test case. Okay, I'm writing the. Okay. So suppose 0, comma 2, comma 4, comma 6. Okay. And then next 3, comma 5. And if I then add 6. So sixth element is I think correct. Okay. Copy paste. Suppose eighth. Incoming correct. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This output is coming incorrect.
Sir, but I got all test cases passed after writing a code.
Your test case is passed?
Yes, all are passed.
Oh, very nice. So let me check
No,
your
I
code.
just copied your code. I didn't do anything.
Oh, still let me check. Name, your name? Shivani?
Smriti.
Smriti. Let me refresh this. So I think some small mistake is there someplace. Smriti, your name is not coming.
Yeah, my name is not there.
Okay, just go through the source code. So this is B2. Smriti. Okay. Oh wow. All are passed.
I think I made some mistake in copying the code, and that is the correct one. But I can't. I don't know. I can't sort it out.
Okay. So here, so now I have to figure out that what you have some change in your code compared to my. So return main essay, I think so. This is the n. So okay, the first thing LE minus SC plus 1, LB minus SV plus 1. This is fine. K equal to 1. Return NC SV. Okay. So you have typed this code, correct? Huh?
Yes, I typed this code while sir was
Hmm.
typing.
So as A S A B S B fine. K N plus N S A. This is okay, and this condition are also similar. BK minus 1, AK minus ASA. And this is also looking similar. So any this call change is there. Okay, so you are using the same mid one. Okay, but
I copied the same code which sir was writing.
mhm.
So the line 28 is different though, right? If K is greater than mid 1 plus mid 2 plus 1, that's what you had?
Yes. So if you see this, if k is greater than mid one plus mid two plus one,
Yeah, that's correct. Yeah.
but I changed this thing as a plus mid one like this. Still,
You
my
did it
code.
just last iteration. Otherwise, it was A of mid 1 greater than B of mid 2.
I didn't change that, right? I think.
Yeah, that you
I
have
don't
to
see that.
change. Okay, so mid one, mid two, kth, essay, mid one plus one. second. So if you see this part, so this condition is okay, and return statement A B S A mid 1 plus 1 L A S B S L B K minus mid minus 1 is fine. Else condition is A B L S A L A S B plus mid 2 plus 1, and this L B. Oh, something is missing. S A L B, but I think the second coordinate is not returning here. So this LB part, not LB.
So one parameter was missing. That's it. My God.
But the code is not giving error. I don't know why. Parameter is
because
missing.
when we have defined 5 parameters,
Hmm.
give 4, it should complain because there is nothing
Yes.
default, right?
And the lower one SA LA SB plus mid 2 K, and then AB SA SA plus mid 1 SB. All are looking fine. Okay, let me run
So
again.
the condition that I didn't give SA plus mid one or something. I didn't see that change. That condition, no? If if
Mhm. Last condition is coming fail for me, but they are passed here. Okay, then I have to check this.
No
But
problem.
yeah, write the code. Okay, you can just try again.
No problem, sir. So I think the whole logic of adding SA is what? Like, so let's say my list A is 100, right?
Mhm.
Initially, my SA is 0, LA is 99, whatever it is, right?
Hmm.
Then when
Yes.
we decide to discard something, let's say we move the left pointer, SA to the right, right?
Hmm.
In that case, what will happen? It will move to the mid. So mid would be 49,
Yeah, correct.
right? So next time when I do, so the SA has been updated. So you have to add SA to now. Why I need to add SA actually to mid one?
No,
Yeah.
actually,
Correct. SA plus
um,
mid one. Yeah, correct. That is because I'm now the new window has become half, and
yes.
starting point is SA, not 0. In the original, it was 0, so that's why it was not dated.
Hmm.
Iteration onwards, we had to add SA plus now the mid one is actually half of the mid one of the previous run or previous call.
Yeah.
So yeah, it makes sense to. But then how is C getting the answer? That's also another thing to think about. Yeah.
Yeah, that is actually I'm also not. Okay, just click the run thing and let me check. Closed. So if print statement is not there, one second. So what is this input test case? This is also big. Okay. Print statement. Oh, one second. This is the part copy. what we are getting in the guest list, ASL. We are getting complete list. Okay. You have writing this return statement. Oh, so yeah, correct. Actually, Smriti, your code is also not okay because you have not called the main function. So what happened actually if the configured answer is the subset of your output, that it cleared the test case actually, and you are returning the complete both list here.
I'm returning the question itself. Huh?
No. So this all values of a, b, zero, len. You are not calling the recursive function. If
Is
you
it?
actually you have not mentioned the name of the function.
Okay, okay, sir.
Okay, just I am putting your the name. Now just check. Okay, so the first test case. I think now your test case will also fail. One test case failed.
Yes, sir.
14. And let's see. Now failed. 2411. Okay, so just now today's near to 11. Just
No
figure out.
problem, sir. We'll try with a fresh mind tomorrow morning. I think it's
Yes. Just try it. Otherwise, we will cover in the next session.
yeah.
Maybe next week we will conduct two revision session.
Yeah.
Okay. So in any other day, we'll try.
Yeah. Now that Python exam is over, sir, so we need to revise some of the old stuff.
Ha.
Yeah.
Yeah. So we will conduct two revisions. So 2 week in the each revision session. I think it will be enough. Actually, we are also handling another course, so that live session is also running. So any session
Python,
is
sir.
not
Python.
possible. No, Python also, C also, C
C
programming,
program. Okay, that's probably a BS level, I guess, right?
BS level and ES, new ES course, no?
Oh, yes. That was
Yeah,
launched.
in the
That's right.
foundation level.
Got it.
That session is also happening. So because of that time issue is there. And also one NPTEL course, competitive programming. Okay, so I'll figure out the mistakes and you can also try, just try to debug the code. Otherwise, logic wise, we are okay, but maybe some small mistake is there in the code. So just figure out this from you also, and yeah, I'll also try. And the remaining question is very simple. I think if you read the problem statement, we are not using any algorithms. Actually, that question is used in one OPP exam. So because of that, we include that in this. So problem number 3. So if you see the question, write a function picking number a that accept a list a and return the length of the longest set of element where the absolute difference between any two element is less than or equal to 1. Are you getting the question?
So that means if we manually scan 465, so we are finding the longest subset where the max of that subset and minus mean of that subset is less than equal to 1. So we are basically putting an upper bound on the range of a subset.
So to sort the list first,
Right?
sort the list first, and then
Your voice is very low. Can you repeat loudly?
sort the list first, and then
Ha.
find the difference between the
Yeah, correct. So actually we want to find out the subset where the difference between each element of the subset is minimum. Okay, suppose if we pick this subset 4, 6, 5. So if you see the difference between 4 and 6, 2. Okay, 6 and 5 is 1, 4 and 5 is 1. So now what is the maximum difference is 2. So this and if we compare like this 5, 3, 3, so you can see here also we are getting 2 difference maximum. But
So,
if we
we
select 4, 3, 3,
can,
then you can see 4, 3, 3 we are getting 1 difference. So this is the length we are asking. What is the subset length? So we can see 3 is the length where the difference, absolute difference between any two elements between in the subset is minimum. No, or less than or equal to 1 actually. Not minimum. Less than or equal to 1.
sir, if we take any set with number of elements n, right, and the possible number of subsets that is done is basically the power set, right, which is 2 to the power n, right?
Yes, yes.
So if we kind of develop a naive solution where if I'm able to write some logic that you give me n elements, I'll create 2 to the power n
Subset.
subsets. Then I go through each of the subsets, like these are my candidate solutions, find the length, and I will select the subset if it satisfies the condition, which is max and mean of that subset is less than equal to 1, otherwise discard it. So then from the candidate list, I'll create another one which will basically be kind of which satisfy the condition. Then within that, I'll find the subset with the maximum length. I know it's a nice
Yes.
doing it, but I think
But just think about the time complexity.
yeah, 2 to the power n, sir. That's what I said. Yeah, naive
Yeah.
solution, I said, sir.
And also this finding the all subset things is not that much easy.
So there's the iter tools we can.
That built-in function you can use.
Yeah.
Yeah, some function is there for this.
Yeah.
But if we sort this list, and then we can simply calculate the difference between each adjacent and check what maximum subset we are getting with 1 or less than difference. So simply the one loop after sorting, this one loop is required to calculate the difference between each element. Okay, so this is not the tough problem. Just apply the sort and use the loop and calculate the difference in between and increase the subset length every time. So at any time, if you're getting more than one difference, just reset your counter and start again from the next. And at any time, if you're getting the more length compared to the previous calculated length, just update your answer.
Sir, in the OPP, there are 2 easy, 1 medium, 2 medium. So was it easy or medium according to you?
This one, easy one.
Boy.
Yeah, it actually it comes in the maybe first or second OPP, first term or second term OPP. So I think this is not much difficult, no?
So this one's complexity will be n square, no? You will need 2
No,
loops.
n log n.
Sorting L log n.
Why you need 2 loops?
To keep the first one and check with the second one.
No, after sorting, what list you will get? 1, 3, 3, 4, 5, 6. Correct?
Yes, sir.
1, 1, 3, 3, 4, 5, 6. So simply you can calculate the difference between adjacent element. What is the difference? 2. Okay, and you can just maintain the length of the longest. So just maintain the one parameter variable, just maintain the length is 2. Or also no need to consider this, because we are finding the 1 or less than subset. Okay, so where the difference is 1 or less than, so we will not consider this. Now we will check for the next adjacent. So 3 3, you can see we are getting 1. Okay, so we are getting 1. Now we will include this length in our longest length so we are getting 2 length where the difference is 1. Now we will not increase this, we will just pointer to this variable. Now we will increase the next variable, next length. Okay, so this 4, so we will compare this 3 and 4, and we are getting 1 difference. Okay, so we will increment by 1, 3. Okay, at this time when we are reaching this node, so 5 we are getting 2. Okay, so 3 and 5 we are getting 2, so we will discard and we will increase. Yes, okay, so we have to use 2 counter. Yeah, correct, we have to use 2 pointer where 1 is running at this point and 1 will running at the next place.
Yeah,
It's
I
like
don't
a
like that
it's like
because
a SA, it's like a SALA, right?
Yes. So till now we are getting this difference 1 or less than 1. Then we will just move the second pointer. At any time we are getting difference more than 1, we will just shift the previous pointer 1 position ahead, and then we will start again from the next element
yes,
in that way.
So it will be n square then, right? Because we are
Ha
comparing.
ha ha. N
Yeah,
square. Yes,
yeah,
yes, correct.
yeah, that's correct.
Hmm.
This is n square. Sorting is n log n, and this is n square. So
This is n square.
it will be n square.
Hmm.
Yeah.
So you can apply this. Okay, so this question is pending now, the solution part. Second question, I will debug this code later, and you just try to write fresh code. Okay, by the logic we have discussed the logic, just try to write the fresh code and try check this answer is coming correct or not, and just check with the smaller input first, then in this.
yes, sir.
Okay, now this is fine. Anything else to discuss? So for the quiz 2, just prepare the conceptual part. Okay. And okay, so in the next we will also release the mock. Okay, then I think it can be closed.
Thank you, sir.
Thank you, sir. Good
Thank
night,
you,
sir.
everyone. Good night.